Chapter 5 functions, we have made it here. Let's jump right in. But first, a nice little bit of comedy. Yours is without a doubt the worst code I've ever seen or ever run, but it runs. Running is super important. We are not trying to get the most efficient, most effective code. We're babies, so yeah, if it runs, that is absolutely a W. So speaking of running, let's jump right in and try to code up in what should be, in theory, an easy warm-up of a program for us. Write a program that will sum 3 sets of numbers and then will display the sum of each. So we want to display the sum of the integers from 1 to 10, from 20 to 37, and then from 35 to 49. So problem solving phase, as always, this is just a warm-up exercise, so hopefully this should be pretty easy. For each set of numbers, make a variable sum, make a for loop that's going to loop from that first number all the way to that second number inclusive of that second number. So when you want to loop from 20 to 37, we really want to do a for I in range 20, 38, right? To go one past so we can make sure we get 37. The step size is of course going to be 1. And then finally print up that final sum. Every time we're going to add that new number to sum and then print up that final sum. This is what we want as an output. So pause the video, try to go code this up on your own in Thani. In theory, this is just a warm-up exercise, but sometimes you got to get the wheels turning, right? We can make some mistakes, that's okay. Pause the video, go code this up in Thani, and then come back. Now I'm going to go code it very quickly here. Make a new program, file new. We have a brand new chapter, so let's save this into a new folder, chapter 6, that I already made chapter 6. You know what? So perfect. Chapter 6. We're in here. Let's make a new file name called Some Numbers. Some Numbers. And I'm going to call it Some Numbers Cheesy, and you'll see why. So we need to sum the numbers from 1 to 10, right? So first of all, I need to make a sum variable. Make a variable called sum and initialize it to 0. Sum equals 0. And then I need to loop over given numbers and add each to the sum. So I need to loop from 1 to 10, do a for loop. I'll just do for I in range 1, 11, since I want to loop to 10. And I'm going to sum plus equals I. I'm going to add the value of I at every iteration. I'm going to add it to my sum. And then finally, I'm going to print. What do I want to print? I want to print the sum from blank to blank is blank. Blank to blank is blank. Formatted printing. So much easier once you're comfortable with it. Dot format 1, 10. The sum from 1 to 10 is sum. Perfect. Let's run that, make sure we get the correct answer, which should be 55. The sum from 1 to 10 is 55. Great. I need to now do the same thing for 20 to 37 and then 35 to 49. So I'm just going to copy paste. Highlight all of that code, hit enter, enter, and then paste again. And so now this is going to be from what? From 20 to 37. That's pretty easy. And here, of course, when I print it, I want to print those values 20 and 37 as well. And then the final sum is from 35 to 49. From 35 to 49. And one more, 35 to 49. All right. Just took a couple of minutes. In theory, should not have been too bad. Let's run this, make sure we get it correct. For, 20 to 30. So I cannot believe I made a mistake. That's all right. See, I like when you get to see mistakes. I decided not to use my brain, and I just typed in 20 and 37. Of course, y'all were hopefully shouting at the screen, recognizing I was making that mistake. I need to go to one past, as I'd already stated up here, and I was being heedless as I copied and pasted. So now I get 513 and 630. Perfect. So I got my output. You should have hopefully come up with something similar. You're like, okay, that seems like practice with looping. Why did we do this? Well, here's the reason why. So here's a similar code or similar solution on the slides. This works fine, But what's the problem? What do you really see that's happening? What's happening is I made this code once, and then I'm really repeating it here, and I'm repeating the exact same code here. You might be thinking, it works. It's a W, right? It runs. That's a W. That's great, right? But when you're repeating code, that's not ideal. So we're repeating that exact same code 3 times. Instead of doing that, or the observation first is that each sum is doing the exact same thing. The only difference is the range of numbers. The first sum is going from 1 to 10, the next one from 20 to 37, and the next one from 35 to 49. So why are we repeating our code 3 times? Well, the short answer is because we don't know a better way. We're about to learn a better way. The question here, wouldn't it be nice if we could write a more general, a more common or vanilla code and then reuse it 3 different times? That would be ideal, and that is the idea of functions. So here's an implementation of that exact same program, but now using functions. And I've given you no explanation, haven't told you what functions are from the perspective that we're now going to study it in this chapter. Of course, we've seen functions. We've seen the print function we use all the time, right? We've commented that anytime you see a pair of parentheses, that's a function. But now we're going to be making our own functions. And here is a solution to that same problem where we've made a function called compute sum, and we're now able to reuse that function. So what I'd like you to do, without me giving you any explanation, pause the video and spend a couple of minutes to try to see what you can understand from examining that code. What can you make out? And this is just a guess, right? You're really spitballing here because I haven't given you anything. But pause the video and see what you can come up with of what's really happening in that code. Just give it a shot. Look at the code, those lines 1 through 5, what's happening there, and then pay attention to what's happening in lines 1 through 7. So now we have an explanation. Given this code, the very brief, this is like a trailer, the bird's eye view of what's going on here, is we've written a function called compute sum. This function takes in 2 numbers that I've very generally called num1 and num2. And inside this function, at least for these first 3 lines, that should look pretty somewhat similar to what we were previously doing when we calculated that individual sum from 1 to 10, for example. We have a sum variable, we set it equal to 0. We do a for loop going from 1 up to not 10, but up to 11, right? So imagine num1 was 1. Num2 was 10, and our code, we had it actually go from what? From 1 to 11. Or if I wanted to do from 20 to 37, I had to go from 20 to 38. So if num2 was 20, and num1 was 20, and num2 was 37, I would go from 20 to 37 plus 1, which is 38. At every step, at every iteration of the loop, I'm merely adding I to the sum. And then I'm returning some which we haven't covered yet. This is, again, just the trailer. So I've made this function, and then I call this function 3 different times within these print statements. I make my 3 print statements, and instead of printing the way you saw here, where I print 20, then I print 37, and then I print that resulting sum, well, here I'm printing 20, I'm printing 37, and then what is that third thing I'm printing? Well, it's really printing the result of this function, which is going to be the sum of the numbers from 20 to 37. You don't need to understand this perfectly when you watch a trailer to a movie. In theory, we haven't seen the whole movie. It's just a trailer. The next several videos that are made will cover this in extensive detail. So what is a function? In short, a function is a collection of statements grouped together to perform a particular operation. And we've been seeing and using functions ever since the beginning of this topic of introduction to computer science, all throughout these videos. We've seen the print function, the input function, the end function, the eval function, In other functions, we've seen so many of them. You've also seen methods, which are similar to functions in the way they work. Methods are, we've seen them on strings. We can say string.upper to print a particular string in fully uppercase, or .lower to print that string in lowercase. So methods and functions are similar in Python. The only difference is that methods are connected to particular objects, such as a string object. We can lowercase or make that the characters of that string lowercase or uppercase. But the overall idea of a function and a method are the same, where you have a group of statements that are a collection of statements that are grouped together to perform a particular task. So in this chapter, what we're going to do is we're going to now cover making our own functions, defining our own functions, writing our own functions. It's going to be super, super cool. So in Python, we need to actually define this function. And a function definition consists of the function's name. It also consists of the parameters that we will send to the function, as well as the body of the function. And here's the overall syntax. We have to type this define keyword, DEF. We then have to give the name of the function. Inside the parentheses, we would list out any parameters, the things that we want to send to the function, and I'll cover that in more detail. And then we're going to have the body of the function, which is that collection of statements that are grouped together to perform a particular task. So the easiest way to understand what a function is and the various components of a function is to really go through a simple example. So our example we're going to cover is going to be a function that will simply determine the maximum of two numbers. It's pretty straightforward, kind of easy. Given two numbers, 8 and 5, which is the maximum number? 8, obviously, and then return that number. But by using this really easy example to go over functions, it helps it be a bit more palatable and relatable as we try to understand the different components of a function. So here's the overall anatomy of a function. So I have this function that I mentioned. It's going to be the function called max. We're going to be trying to determine the maximum of two numbers. So here are two numbers, num1 and num2. Those are the two variables. And we're simply wanting to return the maximum of those two numbers. So we have some logic in here. If num1 is greater than num2, well, that's clearly the maximum. So we save num1 into result. Otherwise, if num1 is not bigger than num2, we say, well, then maybe num2 is the maximum. In case they're equal, it doesn't really matter. But let's say these were strictly values that were not equal to one another. So one of them has to be greater than the other. If num1 is greater than num2, we save num1 to result. Otherwise, we save num2 into result, and then we return result. What does that really mean? We're going to go over those details. But it's a pretty easy function. What is the function header? This is all terminology you're about to see. What is the function header? This is it right here. This define keyword, followed by the name of the function, followed by a pair of parentheses, and inside those parentheses will be 0 or more parameters, each separated by a comma. And then the last thing on the function header is a colon. So here we have define, we have the name of the function max, we have a pair of parentheses. Inside that pair of parentheses, we have two variables, num1 and num2. They are separated by a comma, and then we have this colon. These variables are called parameters. Now we have what is called formal parameters, and then we have the actual parameters. So here inside the function header, these parameters are called formal parameters. The way I like to explain it is to say that they are called placeholders. No value is actually there until you send a value to this function. When you send a value to that function, at that point, that value will then be saved inside these placeholders. And these placeholders are called the formal parameters. The actual parameters are the actual values that are going to be used when we call the function, when we invoke the function, and more details will come on what that means. So when we call a function, that's when we're going to send over to this function the actual parameters that we want the function to use when determining whatever it's trying to compute, in this case, the maximum value. So we're going to have two values here. Maybe the x would be 8 and the y would be 5. Those are the actual values, the 8 and the 5. Those actual values will get sent over and saved into num1 and into num2 respectively. So where are the actual values? They're here over inside your main area of the program, max, parenthesis, 8, 5. Those are the actual values. Over here, or instead of calling them actual values, I'll say actual parameters. These are the actual parameters, 8 and 5. But when we call the function, we're going to send over 8 and it's going to get saved into num1, and the 5 will get saved into num2, and they will get saved into those placeholders, otherwise known as formal parameters. So when you call a function, you're going to be sending the actual values to the function. And these actual values are officially called parameters. Important to note is that parameters can also be called arguments. These are synonyms. So when we call the function, in the last example, we were sending over two parameters, two values. You could also say we were sending over two arguments. Parameters and arguments are synonymous. That parameter list, those list of parameters inside these parentheses, it refers to the function's type, order, and the number of parameters. You don't have to have any parameters for your functions. In fact, we've seen functions with no parameters. I can come up here and type a print function and I run this code. There are no parameters in that print function. Of course, I could type in hello, comma, and then maybe the number 5. That function now has two parameters. The word hello followed by the integer 5. We have two parameters for this particular. So a function can have no parameters or it can have many parameters. That is up to you and what you're trying to accomplish. These actual parameters that you're going to send over to the function, they are received by the function and they are saved into those placeholders that I called, officially they're named formal parameters. So again, here are the actual parameters and here are the formal parameters. What remains is just the function body. That's those collection of statements grouped together to perform a particular task. In this case, the first 4 lines of the function body here, we're simply determining which is the bigger number, num1 and num2. That larger number was saved inside the variable result. And then finally, this last line is what's going to be kind of novel for us. That variable result and the value inside it is then returned. Where's it returned? Well, it's going to be returned to the place from which we first called the function. So this is the function body, and we have a return value here. Not all functions will return a value. Not all functions are used to calculate something and then return a value. Some merely maybe just print something. But a function can compute something for you, for example, and then can return that value using the return keyword. So how do we actually call a function? Remember, a function is a collection of statements grouped together to perform a specific or a particular task. So inside the function, you have that function header, you have your function body, you define those actions, you code everything up of what you want the function to do. But then the question is, how do you actually use the function? How do you start that function? And the answer is, we call it. We call the function, or the other term is we invoke the function. 2 ways to actually call a function depending on whether or not the function returns a value. The first way, if the function returns a value, the way we call the function, we usually treat that call as a value. And I know this is just a lot of words right now. The example is what's most important, and we're going to come to that very shortly. But if the function returns a value, the call is usually treated as a value. So the example here, if we wanted to call that function max that we just made, I could send those two parameters to that function. In this case, I'm sending over 3 and 4. Obviously, 4 is the larger number, and 4 would get returned. And when it gets returned, I would save it inside this variable larger number. So here, if a function returns a value, we normally treat that function as a value. So you can see this is an assignment, and an assignment, you take what is on the right and you save it into the left. So this max function will return a value 4, and therefore I'm treating the entire function almost as a value, because I'm going to take whatever it returns and get it saved inside this variable larger number. Or what if I wanted to just print it directly? I could have said print the max of 3 and 4. So that maximum value between 3 and 4, which is of course 4, will get returned, and I just print it directly. So that's how you would call a function that is returning a value. But what if the function does not return a value? Instead, it just maybe prints something. Therefore, the call to that function would look like just a basic statement. So if here we have this function called print this, it's a very exciting function, right? That function is called print this. It has no parameters, and all that function does is it has a print statement that says, hi, we are now printing from inside a function. We've created that function. How do we actually call that function or start that function? We simply, as a basic, simple statement here, I type the name of that function, print this, followed by parentheses. There are no parameters of this print this function, and it doesn't return anything. Let's actually look at that one. So if I wanted to make a function called define print something, I'm going to put a pair of parentheses. So I have to put the def keyword, and you should code this up as well. I put the name of the function, print something. I put a pair of parentheses and a colon. And here inside this function is the body, and I'm going to just type, we are now printing inside the function. This is super duper exciting. Pretty simple. We put 2 print statements. Let's put a third one. The third one, hello world. There we go. So now when I run this program, what happens? Nothing happens. Do we understand why nothing happens? Perhaps we're a bit confused. Why aren't we seeing those 3 lines of output? Well, because a function is something you're merely creating that you can choose to use or not use. In this case, we created the function, but I never actually called it. And so in fact, if you were to debug this, you would see that Python says, cool, I see you got a function, appreciate you. And if you just if you click step into, that's the end of the program because you never used the function. So how do we actually start the function? We simply type the name of the function with parentheses. And inside the parentheses, you would put parameters if you needed them. In this case, there are no parameters expected up here, right? This is where you would have the formal parameters, AKA placeholders, right up here, but there were none. On this particular function, there were no parameters, so I'm not going to specify any down here. So now, because line 8, what's happening on line 8, or now line 9, what's happening is, now we will start the function, print something. How are we starting it? We are calling it. Line 9, this is called, we call this the call to the function, or we are invoking the function. So now when I run it, I get those 3 lines of code. So you could write a function, but nothing will happen or it won't get used if you don't call it. So I just ran it again. Nothing happens because I did not have the actual invocation or the call to that function. But now on line 9, when I put that back and I run it, I get some output. So that's how we can call a function. Let's go now revisit and code up that full program that we were just showing. We want to write a program that will call another function max to determine the maximum of two numbers. The function max should return that maximum value. So even though we already saw it when going over the anatomy of a program, let's now discuss it before we code it up. Step 1, problem solving phase, we have to have in our main working area two integers, and we need to have the values for both of those integers. How do you get those values? We could ask the user to enter two numbers. You could generate two numbers randomly. That's not really important and part of the purpose of this example, but we still need to make two numbers. When we code it up, we could just put two numbers and hard code it. I'll go ahead and just ask the user for two integers because it's pretty easy to do here in Python. Next, we need to actually create this main function, this max function, that's going to return the greater of those two numbers, and then we need to call it. So we're going to call this max function, and I say here now backwards that we need to, of course, therefore write that max function. I say it should be easy, and that's not going to be easy because it's going to be the first time. But we want to just have that if-else logic to determine which of those two numbers is larger. Save, if num1 is larger than num2, save num1 into result, else save num2 into result, and then finally return that number. So here's a solution, but I want to come over here and code this up. So file, new, save, demo, max function. So define function max, I'm putting a comment here, to return the maximum of two integers. So define max, and we have to have two parameters. Num1 and num2 is what I'm going to call them. You could have called them A and B, but use a good variable name. So it is two numbers, so I'm going to call it num1 and num2. What was the logic we already saw previously when we looked at the anatomy of a function? We had if num1 is greater than num2, do what? Take num1 and save it into result. I'm going to call this the max. I'll do that. Save num1 into the variable called the max. Else, if num1 is not greater than num2, save num2 into the max. Pretty easy. And then finally, we need to return the max. So return the max. This is the function. And again, if I don't actually call the function and I run my program, nothing happens, right? So we want to actually call the function, which means we need two numbers. So I'm going to say num1 equals int input, enter an integer. And then num2 equals int input, enter an integer. And now let's call that function. So ultimately, I'm going to call the max function. I'm going to send over num1 and num2. But remember that this function, it's going to determine, like these 4 lines of code should not be confusing. That should be very clear. Just comparing which is greater, saving it into a variable. After doing so, this function is going to return that maximum value. So the result of this, if I sent over 8 and 5, this is going to become 8. This will then become 5. And then this function is going to return 8, right? That's what's going to happen. So the result of calling this function, when I send over 8 and 5, the result of all of that will just be 8, because 8 is what gets returned. Well, because 8 is what gets returned, or the maximum number gets returned, as we mentioned, a function that returns a value, it's good to treat it as a value, which means we want to save if it had returned 8, for example, if all of that was 8 after calling the function, well, we want to save 8 into its own variable. So let's call this the max number. So now hopefully that's very clear. So I have these two integers. I then call the function, and I'm going to save its result into the max number. I'm going to then print the result. Print the results. Print the max of blank and blank is blank. Dot format. Formatted printing is so easy. Num1, num2, the max number. So hopefully you understand this code. Pause the video and make sure you code this up exactly the way you see here. Pause the video, and then once you have it fully coded and working, run it and test it. We're going to debug this together, and we're going to see where Thani truly shines. And I've mentioned that on the slide as well. Thani truly shines as an educational IDE, when you use its debugger on functions. So here I'm going to type ask the user to, or prompt the user to enter two integers. Here we will call the max function, send over the two actual parameters, and save the result into the max number. All right, so make sure you coded this up, pause the video if need be, and then come back. Let's run this first to make sure it works. Enter an integer, 7. Enter another integer, 9. The max of 7 and 9 is 7. Cool, let's test it again. Enter an integer, 7. Enter another integer, 6. The max of 7 and 6 is 7. So it works just fine. Let's debug this. This is where it's going to be so super cool. So hit the debug, and then watch what Python does, how the interpreter works here. Remember, on a Windows-based machine, it's F7 to hit step into. So here, the first thing is the interpreter says, we have a function. Cool. I got you. And that's all it does. It doesn't execute anything. It's just a recognition that you have this function. You know what? Let me hit stop, and let me go to view variables so we can see the variables at the same time. Because here in Thani, it kind of treats that function as a variable, which is weird, but it's okay. I'm trying to maximize this as big as I can so we can see it on the screen. Let's debug this again. So again, Thani sees you have a function, and it really just makes this variable called max. It's not a variable, but it's just recognizing, okay, cool, you got a function. Maybe you'll use it, maybe you won't. So I'm going to keep hitting F7 over and over. Finally, the program has paused. It's waiting on me to give input. Let's give the number 7. So it says 7 is the input as a string. Now it's going to convert it to an integer. It did that, and it's going to save 7 into num1, as you see right over here. Now, we'd have to do this again. I'm going to keep hitting F7, and let's make the other integer 6, and we save 6 into num2, as you see here. And so now we're at this line of code, line 16. It's an assignment, so the interpreter looks to the right side, and it sees this function, max of num1, num2. Now, these are the actual parameters, so it's going to take the 7 in num1, it's going to put it right here. It's going to get the 6 from the variable num2, and it's going to put it right there. And now we're going to call this max function, which is this function up here. We're going to call it with these two numbers, 7 and 6. And when I hit F7 again, look what happened. This is so cool. What happened is we get a brand new window that popped up, which is where Thani shines as this educational IDE. Because this new window, it's really like a mini program, a function. Think of it as like a mini program, that collection of statements grouped together to perform a task. Well, now I've called this function. The function's called max. And remember, we sent over num1 as 7. So this is 7. And num2 is 6. So now let's keep on running the function. The interpreter has already highlighted these 4 lines of code. This if-else block, it sees that one block of code. And it's going to check, is num1 greater than num2? Is 7 greater than 6? It is. That's true. So it's going to take num1, which is 7. It's going to save it into the variable the max. So now we have a new variable. The max is 7. Of course, the else part we don't execute because the if condition was already true. So we have the variable the max which stores the value 7. And now we need to return the max, which is 7. So we're going to return 7. Now I haven't hit F7 yet. I've paused right here. Where is this 7 going to get returned? It's going to get returned to the exact place from which we called it. So here we were in our main program, we were on line 16. We said the max number is, and we have max of 7, 6, right? The max number is, and we called that function. So now we're going to return 7 to right here where we called it, max of 7, 6. So check this out. When I hit F7 again, we're returning 7 to right there. All of this right here, max of num1, num2, it became 7 because we called the function did its thing, it returned 7, and 7 was that maximum number, which we're going to save into this variable, the max number, which is now 7, and finally, we can now print, and we print the result, the max of 7 and 6 is 7. I'm going to debug that again, and I'm going to go a bit quicker this time. It's just so important to debug this. If you're ever confused on functions, debug it. It's super cool. So here I'm going to put a different set of numbers. I'm going to put 7, and I'm going to put 9 for the other number. So now the second number will be the maximum. So here I'm going to send over 7 and 9. Those are the actual parameters, 7 and 9. And those parameters are going to be stored inside these formal parameters. The actual parameters, 7 and 9, were sent over to these placeholders, which are the formal parameters. So this is 7, this is 9. If 7 is greater than 9, which is going to be false, so now we come to the else, and it's assumed that therefore 9 is the larger of the two numbers, which it is. 9 is saved into this variable, the max, which is returned. We return 9, and again, this is like a mini program that's running, but it's about to finish, because when I hit return 9, now we go back to our main working area. 9 is going to replace this right here, this max of 7, 9. 9 will replace all of that and will get saved into this variable, the max number, and then we just simply print the result. Super, super helpful and important to debug all of that and understand that in that Thani debugger. So here's this slide called Who is in Control? Program control. When you run a program, the control of the program is in the regular area of your program. I will refer to this area as main, meaning when I run the program, the Python interpreter, it sees we have a function. It just says, okay, it acknowledges that fact. And then it continues with the regular area of your program. I'm going to call this the main working area of your program. This is called program control. When you call a function from main, program control leaves the main working area, right? And what happened? It then goes and it calls that other function. So when I debug this and I hit F7, I'm gonna do it again very quickly. Enter the number 2, then we enter the number 8. What happens here, we have this line of code 16. Program control is currently in the main working area, right? This is who's in control of the program. But when I call a function and I send over those actual parameters and I call this function, now your main area over here, all of this code, this main area, it's on pause. Program control just left your main working area, and now program control is at this max function. Right now, this is basically paused. We can't go to line 19 and try to print because the function is being executed right now. So program control has left your main working area of your program and was transferred to your function. Main is basically on pause, and it's waiting for the function to finish its job. Once the function finishes its job, program control then returns to main, and the function returns control to where it was called from. How does that happen? When it returns, if that function is returning a value, or simply when the function finishes its last line of code. So with all of that said, why is that valuable? It's valuable for many reasons to understand where the actual execution is occurring. Is it occurring in your main working area, or have we transferred program control to a function? That's important. But also it's important because now we're finally going to make a main function. I just referred to that main working area of your program as your main working area. Why? Because most languages, you look at all of the C languages, C, C++, C#, Java, most languages actually define this main working area as a main function or as a main method, your main entryway into your program. By default, Python doesn't need this, right? We can just come into our garbage here. Let me close this, stop debugging. I can come to my garbage, this print something, and I can just start typing, right? We don't need to have a function. I don't have to have some main function. I can just type print hello. I don't need to put that inside some other function. But in other languages, all the C languages, Java, most other languages, all of your code must exist within some function. And even if it's a basic code, your code must exist within a main function. That's your main entryway into your program for most languages. And so most Python developers will have this same custom, the same habit, to put all of your code inside a main function. So notice I have all this code right here where I prompted the user to enter an integer. I then saved those two numbers and I called it and I printed it. We don't currently have that code as part of a function, but I'm going to highlight it. I'm going to hit tab, and on line 12, I'm going to say define main, colon. And I just realized I still have that confused look. That is fantastic that that is still on the screen. Love my Stream Deck. Sorry about that. So here I type define main colon, and then if I run my program right now, nothing's going to happen, right? Because now I have a function max and I have a function main. That's not really helpful. I need to call that function main. So here on line 23, start the main function. How? By calling it, by invoking it. So I'm merely going to type main with a pair of parentheses. So now this is the traditional way of coding up any basic program. You put all of your code into main, into this main function, and any other function, you put your code in those other functions. But even if you want just a hello world, our first program we ever coded was hello world. Well, the correct way of coding this program, this works, but the correct way would have been as follows if we knew functions. We would really type define main, hello world, and then here on line 4, I would invoke main. This is the correct way of actually executing a Python program, by putting all of your code, even in the smallest of programs, by putting your code inside a main function. So here on out, any program we make, even a tiny one, we will put that code into a main function. So let me just end by simply debugging this main function so you can also see now two functions pop up when we debug it. I'm going to go through it quickly, but the first thing the Python interpreter says, okay, I see you. You have a max function. Cool. We hit F7. Python's like, okay, I see you. You have a main function. Cool. It doesn't run anything. But now we get to line 24 and Python's like, oh, gotcha. You want me to actually start the main function? No problem. We'll call the main function and check it out. Now we've left the main working area of that Python program and we've invoked or we've called this main function, which is right here. So now if I keep debugging this, it's going to ask me enter an integer. I enter 8. It asks me enter another integer. Let's say I enter the number 5. Now we're going to call, remember, we already have one function open. This is the main function. And now I'm going to call the max function with 8 and 5. And now we have a new function. This is what's really cool with Thani as a debugger. We have the main working area over here, which is on pause. We called the main function. Here's that main function right here. And we're trying to execute this main function. Well, on line 11, we called the max function. So this is now on pause as well. So now let's finish this max function over here. Let's hit F7. Is 8 greater than 5? It is, that's true. So we will be returning the number 8. Where does this number 8 get returned to? It gets returned to right here, this line of code that we were trying to execute. That becomes 8. The maximum number is 8. Now we print the result. The max of blank and blank is blank. The max of 8 and 5 is 8. We print that result. And this function now is still open. It finally finishes. It gets returned. And now we're back here in main and we're done. That's super cool. This debugger in Thani is incredible to get a visual of what's happening with these different functions. Guess what? We are now done, that we've traced that through. Make sure you're good with that. As always, reach out, ask questions, leave comments. It's been fun. Take care, everyone.